Yes, hello. This time we make a short interlude, let's call, uh, because we need to talk about some coding. Yeah, we will use some stuff, and maybe I have some hints for you, which are okay for you, yeah, which you can use. Because now we really start to start code. This is our program here. Yeah? We've just written this. Yeah? In the last task, we have written this, and you know there is this thing. If I type in 5, then the LED number 5 is turned on. Yeah? This is what we coded. So let's see how could we manage if I don't want to turn on the LED number 5, but LEDs from 0 to this. So if you ever want to turn on 5 LEDs, let's say, if this 5 would mean turn on the first 5 LEDs. Yeah? What can be done about this? Okay, so here is the code part, yeah, where we are reading the number is now something between 0 and 7. Yeah, of course, if I want to interpret now the number, if I want to turn on 0, 1, 2, 3, I would have to use up to 8. I would allow up to 8. Yeah? So that's one change. Okay? So now we can enter 0, then 0 LEDs should lit. We could enter 1, then 1 LED should lit. We could enter 5, then 5 LEDs should be lit up. Okay, so this is in the number. This is what sets in the number. Okay. One possibility, the number is an integer. One possibility is to make it with a so-called for loop. Yeah? The for loop looks like this: for, okay, then bracket, the variable I want to see. This is the number, so I want to look at the number. Then there's a condition until the number is bigger than 0. Okay. Of course, semicolon. Here should be a semicolon. Until the number is bigger than 0, decrement the number. Okay. This means if the number is 0, we will not even get in. If the number is 1, number is bigger than 0, it will run through, then decrement the number, then it's not bigger than 0 and stop. Yeah. So this one we will shift over here. Now we set the bit in the LEDs byte, yeah, and with the number. Okay. And then we update the shift register. That's it. Yeah. Here I want to show you how this is working. Turning on lead count. Yeah. And here right after if. After 4, of course. After 4. X is okay, and of course I need to delete before the LEDs, yeah? Because I'm filling up the LEDs with my new number anyway. So if I type in a new number, I will delete whatever is an LED, so no LED would be lit. I don't see it because I don't call update shift registers. Then I look how many LEDs I have to turn on, and for every LED I have to turn on, I'm setting one bit in this LED. Yeah. If I enter, for instance, 3, then there is 3. Then on the first run through, I will set the bit number 3. Second run through, I set the bit number 2. Next run through, I set the bit number 1. Yeah. Next run through, I set the bit number, I set no bit number anymore. Yeah, we will see what this is causing. Okay, So I will now upload. And then now enter 1. I would not have expected this. It's not the first one, it's the second one. But it's one LED. Yeah? I enter now 5. Okay. It's 5 LEDs. 1, 2, 3, 4, 5. But also the first one is not lit. Yeah. And here on the output we can see lit count 5. After 4 it's 0. So it's counting down. Okay. There should be maybe a space. But why is the first not lit? Because of course I have to use number -1 here. Because I want to not to turn, if I type in 3, yeah, I don't want to turn on LED 3, but 2, 1 and 0. Okay. Upload once again. Make it big. Clear output. 2. Whatever. 0. Nothing. 2. 2. 7, 7, 8, 8, 4. You see, now it's working fine. So this would be one possibility. This would be one possibility to turn on the LEDs with this 4. Okay, so the 4 needs an integer value here, a condition, and what should be done with the integer, and then in the body it needs some commands. Yeah. We could even, for instance, to see how this is working, we print here the number always. Yeah. And then we also print a space. Well, let's print this. Then we see exactly how this number is always counting down. Okay. So I'll type in the number 5 now. 5, 4, 3, 2, 1, 0 is not executed in here anymore because the number must be created to be then 0 to enter this. Okay, that's the for loop approach. One possibility. Now even the output should look very nice. This is sometimes I'm giving 7, 6, 5, 4, 3, 2, 1 after 4, 0. Wunderbar, wunderbar. Okay. So you see, this you could use. Yeah. But let's say we want to turn on a specific, or let's say we are now will do another approach. Okay, that's one possibility. One other possibility is that I define a so-called array. Okay, array is nothing more than, I will simply show you. Yeah? So so we will need some byte arrays, yeah, byte, that's the type, and I'll type in I will use a name, that's the patterns, that should be my patterns, and I want to have 8 patterns. Okay, this is how an array is defined with these brackets. These brackets, I define an array. Now this is not just 1 byte. This is not just 1 byte. These are now 8 bytes, and I access it. How I access it, I'll show you afterwards. If I make it like this, yeah, then whatever is inside patterns is not initialized. if I want to have something inside, yeah, I could write something like this. Okay, and now I can define some values: 0, 1, 2, 3, 4, and so on, whatever. Yeah, it must be 8, of course. 5, 6, 7. Close the bracket. Semicolon should be able to compile it. Yeah. And below here, I could simply forget about this. Yeah. And could say I turn on patterns of number. Yeah. So if the number is 0, yeah, then I will use this one. If the number is 1, then I will use this one. If the number is 2, then I will use this one. If the number is 5, 0, 1, 2, 3, 4, 5, I'm using this one. Yeah. Notice we don't even need these LEDs anymore. Yeah, it's not. I can remove this by simply, and I can remove this line. I am also, it's gone. Simply, I've substituted this with these patterns. Yeah. Download. See what's happened. 0, nothing. 1 LED, 2, second LED, 3, 2 LEDs. Why is that? Yeah, because these are values here. Yeah, so 0 is a 0, was okay. 1 is okay. If I want to turn on 2 LEDs, I have to make it 3. If I want to turn on 3 LEDs, I have to make it 7. Yeah. If I turn on 4 LEDs, the 4 LEDs, this digital representation is 15. Yeah. If I have 15, it's the 4 LEDs. Then we have 31. Yeah. Then we have 63, and then we have 127. Yeah. If I use these values, yeah, then this should work. Turn on 1, 2, 3, 7, 8. Oh, what is 8? Yeah, you see, now I have run into trouble, because I am accessing 8, and this is 0, 1, 2, 3, 4, 5, 6, 7. 8 would be the next byte. I can access this, as you see, but it's not, I'm not using 8 patterns, I'm using 9 patterns. Yeah, 0, 1, 2, 3, 4, 5, 6, 7. And that's 255. Okay, so there you need to be careful. You can access the whole memory. Yeah, it does not check if this array is ended or not. I could even ask patterns 126. Then I would read some byte which is way beyond. Yeah, so there, I don't know what is inside the memory there. Nobody knows. Yeah, it's just luck. There you have to be really careful that if you're defining an array with 9, then you have to take care that there's no more than 9 you're accessing. Let's see, 8. Now it's working. Wunderbar. The only thing which we don't really like, or which I don't really like, is that I have to think about what bits, or how the bit pattern that I always have to calculate between the decimal representation and the binary representation. Binary representation would be fine here. Yeah. To have binary constants, I can mark it with B, and then I can write 1 byte. Yeah. And I can even write in the next line. Okay. Do it again. Now I want to have 2. Now I want to have 3. Now I want to have 4 LEDs lit. Okay. Now I want to have 5. Now I want to have 6, 7. So 1 is still missing. I have to enter the zeros here. And of course, B 1 1 1 1. Ooh, a little bit too much. Okay. This now gives me much more idea which LED will be turned on. Download, upload, upload. I don't know why this is up and I'm down, but okay. 5. See? 5, 6, 7. It takes these patterns. That's a nice feature, I think, because we could even select real a pattern here. Let's say 1 means only 1 between, 2 means 2 between, 3 means 3 between, 4 means 4 between, 5, then there would be no difference. Yeah. Download. So 7, 6, 5, 4, 3. See? 3 is now the pattern. Yeah. The pattern of 3 was 1 1 0 0 1 1 1 1 0 0 0 1 1 1. Exactly that is. 2 would be 0 0 1 1 0 0 1 1. Yeah. Let's try 2. Yeah. 0 0 1 1 0 0 1 1. Perfect. Let's try 1. Every second LED should be turned on. 0. No LED should be turned on. You see, this might help, yeah, to do also patterns which are cannot be easily calculated. Just by defining this as an array. That's the big advantage of an array. You're much more flexible. The disadvantage, you need more memory, because now here I need 9 bytes. Before I just used 1 byte. Okay. One thing is also to mention, these patterns, I could overwrite them. Yeah? That's maybe a nice feature. Yeah? If I say, okay, pattern number 5 is now something else, if I want to go sure that I do not overwrite those patterns, I can use the keyword const. Okay, Ctrl D makes it perfect. Const. Now this is somehow protected, these patterns. If I try to write it, the compiler will say, hey, you try to write on a constant value. This is not possible, my friend. Yeah? And will give you an error. Yeah? So here, for instance, if I write here pattern number 1 shall be 1, if I try this and compile, how is it called? Patterns. Sorry, because Right now it tells me it is not declared. Yeah? Would also be an error, of course. Compile, and there's a assignment of read-only location. Okay? So this means you have defined it as constant. If I delete this constant, I can compile it. Yeah? So if you want to get sure that you cannot override this because it has to be constant, use the const. Yeah? Then the compiler is checking if you maybe have some coding error somewhere. Okay, I hope this little introduction, this little coding hints help you with your tasks. Yeah. Yeah. Next time, then we will see. I think you can pretty well use especially these ones. Okay. So long. Thank you for your attention and goodbye.